In this demo, we're going to explore a visual question answering system. You may know that neural networks are getting pretty good at recognizing images. So for the last 5-6 years, we've been able to reliably ask a network whether there's a dog or a cat in a picture and get mostly correct answers. Visual question answering is a step beyond that. We want to explore whether the network really understands the image by asking it questions about it. The dataset we're going to use in this demo is called CLEVR, and it was generated by a Stanford team. They created artificial scenes that, for example, look like this: a bunch of objects on a tabletop that have different shapes, materials, colors, and sizes. And they also generated a number of questions about these scenes. The first example here says, are there an equal number of large things and metal spheres? So as you can see, this question is a bit more difficult to answer than is there a dog in this scene, because we have to count large things. So I would say there's 3 large things in this image, and metal spheres, there is probably 3 metal spheres as well. This particular sphere is not metal. So the answer to this question would be yes. But the neural network needs to do a bit of reasoning in order to answer a question like this. Lately, models have gotten pretty good at doing this task. We're going to look at the MACnet model written by Hudson and Manning in 2018 and described in this paper, Compositional Attention Networks for Machine Reasoning. In this demo, Ekin Akgüret, my student, ported the MACnet model to Julia, and in this first code box, we're basically going to be setting up the demo, loading the data and the pre-trained model. So I'm going to hit Shift Enter until we get to the exciting part. So this is all set up, and all right, finally we have an image. So each time you run this notebook, you will probably get a different image from the dataset. In the next code box, what we see is a sample question and answer pair from the actual dataset. So the question is, there is a green metal object that is the same shape as the yellow shiny thing. What size is it? So here's the yellow shiny thing, it's a sphere, and the green metal object that has the same shape is another sphere, and its size is large. So the gold answer was large, and the model was able to predict the correct answer. More interestingly, we can actually answer our own questions. Let's go back and look at the image to think of a nice question. So there's a bunch of cylinders, for example, and I wanted to focus on this cylinder. So I'm going to say, what color is the cylinder to the right of the cube? And we get the correct answer, gray. So let's look back and make sure. Yes, so there's only a single cube. To the right of the cube there's a cylinder, and its color is gray. Now, more excitingly, we can visualize what's going on inside this model. This model actually works by 2 attention mechanisms that run in parallel. One attention mechanism is basically paying attention to different words in the question. Another attention mechanism is looking at different regions of the image. So we can almost peek into the model and see how it's actually thinking while answering this question. So in the first time step, we look at the image. It's not paying attention to anything particular, but on the language side, it's basically paying attention to cylinder and somewhat to the word cube. So in the next image, we basically see that it's actually paying attention to these light colored squares, show us where it's paying attention to, and the attention is divided between the 3 cylinders. So the word cylinder is used to pick up the locations of the cylinders in the image. In the next time step, as we see, most of the attention is given to the cube, and if you look at the next image, we see that it's actually paying attention to this cube a bit more, and finally we're paying attention to the question, what color. It's not always trivial to understand how these attention things shift, but it finally shifted its attention to the correct cylinder, and at this point it probably has the answer gray. So you can use this notebook to explore different images and different question answer pairs. You can ask your own questions and look at how the attention of the model actually shifts